Hello everyone and welcome to our next edu series. In this video we are going to discuss about CICD simplified with AWS. First, let's look at the highlights of this video. Why manage services for CICD, the benefits compared to the other manual approaches like Jenkins. AWS CICD architecture, the key components, then things to remember particularly during the implementation phase. And finally, we will do the practical implementation. So let's begin. Why AWS for CI/CD? Number one is it's a managed service, which means AWS itself manages the complete CI/CD process, and it is totally automated. The second is AWS Security. Third, AWS Scalability, and finally, seamless integration with other AWS services. First one, fully managed and scalable service. AWS CodeCommit, CodePipeline, CodeDeploy, and CodeBuild are fully managed services. They are serverless technologies. AWS handles the underlying infrastructure such as servers, scaling, and maintenance, allowing us to focus solely on development and deployment processes. Unlike Jenkins, which requires self-hosting and maintenance, AWS services automatically scale to accommodate growing projects without any manual intervention. So this makes it very easier for teams to manage their CI/CD pipelines and reduce their operational workloads. Second is the seamless integration with AWS ecosystem. The services like CodeCommit, CodePipeline, and CodeDeploy, and CodeBuild, all the services are the AWS native. Integrating with other AWS services like EC2 instances or EKS within the AWS makes it very easier. The next is the security and compliance part, which is AWS Identity and Access Management, IAM, and the multi-factor authentication. That's the added benefit which we get from AWS. And then the next additional security layer is AWS KMS, Key Management Service. Secure your data at both the layers, data in transit and data at rest. So now let's discuss about AWS CI/CD architecture briefly. Here we have three layers. One is the source, is the connectivity between the Git local repository and CodeCommit remote repository will be established through IAM user authentication. The process will be like we will be registering IAM SSH and then creating appspec.yaml file, which is very important, that will instruct what needs to be done for this particular application. And then we need to push the code to the CodeCommit. And then in the deploy or code build procedure, we have create application, we create deployment groups, we create service roles, and then assign to the target. In this video, we have chosen EC2 as our target. We have two options here. One is code build and one is code deploy. You can go with either of them. Code build, what it does is it builds your application internally and it validates your code and then finally deploys to the target. And if you go with the code deploy, that does not build or test the code, rather it will directly push it to the target instance, that is the EC2 instance in our case. And then at the target we have EC2 instance. Here the points that we need to remember is to install the code deploy agent at the target and then add an IAM role to the console to the AWS instance. Now briefly about the steps that we are going to follow for the practicals. Set up EC2 instance, run a basic HTML code in it that will function as our website. And then we will install Nginx, creating a repository in CodeCommit. We will install a Git bash on local PC through where we are going to connect to the remote repository, that is CodeCommit, generate SSH public key to register with AWS IAM. Copy Git link SSH, add files, push the code and check whether it has reached inside the repository of CodeCommit or not. We will also create an appspec.yaml file that will have the instructions what to do about this code. And then we will be moving on to the code pipeline, the second layer, and then code deploy procedure. Here we will have the EC2 instance, install the code deploy agent, create IAM service role, create code pipeline, and then finally we will have the create deployments, deployment groups, and then we'll push it to the target. So let's begin. Here I have Terraform script what I'll do is I'll just move on to that location. I'll just give the Terraform apply. So now we have our EC2 instance. Let's log into the instance. I have my key pair, which I used while creating. So my EC2 instance is ready now. Part of the next step, I will move on to the console, CodeCommit repository. We'll create a new repository. So now having three options, either I can use HTTPS or SSH or HTTPS gRC. Step one, as a prerequisite, we need to install the Git client. The Git client installed. This is how its interface looks like. It's a command line interface. So I'm using this Git local as my local repository. The next step, it's to register my SSH public key. Follow the link, SSH keygen, give my passwords, and my SSH is established. To go to that respective directory and then copy the contents. Then to the IAM. I'll go to security credentials, the SSH public key. So I'll upload a new public key over here. I'll be pasting the lines which I copied. Then finally upload. Here it is. Now this is done. I'll copy this SSH key ID, edit the SSH configuration file. So there will be a configuration file in the same location. Copy the code as given on this page. Now let's clone the repository by copying the command as given on this page. Done. Now, so we have registered our local kit with the remote CodeCommit repository. Test the connection from our local kit repository to the remote repository. Let's check the Git status. It says no commits, yes, nothing to commit. So as I said that I have my own index.html file which has the HTML code that is sufficient enough to display it as our first landing page of our website. I'm just copying that. This is the index.html. This is my HTML file. I will also copy one appspec.yaml file. I will show you the contents and install dependencies.sh file. You can also add other files along with this, like start server or stop servers kind of dependency files. The instructions for which you will be giving inside this appspec.yaml file. So see the appspec YAML file. The contents is PRO. The file contents is, we are just mentioning what is the source that needs to be copied, like the index.yaml file, index.html file, and then the destination at the target EC2 instance where we need to copy. The destination, you can see that us/usr share nginx HTML, because that's the default location for any HTML files to be executed if we are running through nginx. Then we have this before install block where we will be mentioning a location of the file that needs to be copied, that is install dependencies.sh. So this file also will be copied to the required location at the target. And this install underscore dependencies will instruct what to be done before we copy the file. So what we are doing is we are just removing if there are any index files. So these are the 3 files in our local repository. Git add, switch to our main branch, Then we'll commit the changes. Before pushing the files, let's go here and then verify if there are any files in our repository that we created. Repo for video, the one which we created, it's still empty. Git push origin main. It asks for the completed successfully. Refresh this again. Now here we see all the three files are moved to the CodeCommit remote repository that is on AWS. Now let's move on to the second layer where we'll be building our code pipeline and then utilize that pipeline either with the CodeDeploy or with code build. Pipelines. I say create a pipeline. We can go with an existing service role or we can create a new service role. Service role for video. Allow AWS code pipeline to create a service role so it can be used with this new pipeline. In advanced settings, it asks for the artifact store. We can choose the default location or we can add a custom location where we can give the S3 location as our artifact store. Encryption, we will use the default AWS managed key default. Next, it asks for the service source provider. We will choose the CodeCommit because that's the source on the AWS. The repository, the repo for video. And then it asks for the branch name. We'll choose the main branch as the branch because that's the main branch that we have chosen here. And then change detection options, which means how you want AWS to know whenever a code is committed and pushed to the repository, so that how this pipeline will come to know whether there are changes inside the code and the developer has already pushed their updated code to the code commit. So that's through, we have multiple options. One is the Amazon CloudWatch events. If a developer has pushed a new code to the code commit repository, CloudWatch events immediately identifies the change and triggers an event which will call the code pipeline to pick up the new code and then deploy it to the target EC2 instance. Hence, it is a recommended approach. And now this is another benefit of having AWS CICD, that we will get the advantage of AWS CloudWatch events. So as we discussed in the beginning of the video, we have two options, either to go by cloud build stage or by cloud deploy. So we will skip this build stage. Now it says you cannot skip this stage. Pipelines must have at least 2 stages. Your second stage must be either a build or deployment stage. So we have chosen the deployment by skipping the build stage. Now we use the deploy provider. AWS CodeDeploy is the one which we have chosen. We need an application name. We can use an existing application, or if we do not have an existing application, we need to go back. Under CodeDeploy, we have the application. We create an application. Now we have two options of deployment. One is in-place deployment and the other is blue-green deployment. Now the option we have is, here we will use the tag values. It says one unique matched instance, which means it has identified target EC2 instance based on the tag value Complete the required prerequisite before AWS System Manager or can install the CodeDeploy agent. So I will be giving the set of commands that will install the CodeDeploy agent in the description below. You can use those commands to install CodeDeploy agent. Now that the agent is up and running, we'll go back to our deployment page. We'll go ahead and then create this deployment group. Deployment group is created, and two things: one is application is created, one is deployment group is created. So let's come back to the pipeline again, do it again. Now we have the application app for video, then the deployment group, dpgrp for video. Next, and then create the pipeline. Now you can see the source is ready and the deploy is ready. It says the source is in progress, deploy did not run yet. So we just have to wait for some time. Now it says it succeeded, which means the source, it has identified the source, and deploy is in progress. All right, then the source is succeeded and the deploy is also succeeded. So now how do we verify that? We will go to the EC2 instance. Good. Now we have the public IPv4 DNS. Because we have the DNS host names enabled at the VPC layer, any instance that is getting created within this VPC will have this DNS names. We'll copy this DNS names, then just paste it here, then run it. Since that we do not have the HTTPS enabled, we'll go by HTTP. There you are. So our web page is. So now let's have a look at the errors that we encountered during this practical implementation. Fine.